So we begin our glass chapter talking about some properties of glass. So we have a couple of class and individual properties about shards of glass that we might find on a crime scene. One, the only individual characteristic we really have is that if I were to find some shards of glass and I could edge fit them together, like so a piece of glass broke and some of the shards were from one source and some in another. If they fit together, they pretty much had to have come from that same original piece of glass. The fracture patterns are so different when they would break that I can say that. So this becomes particularly important with car accidents when we have if the vehicle has left the scene or there's some question about it, that can be very helpful. Also, that same idea of edge fitting can work with things like duct tape at a crime scene or lottery tickets that have been fraudulent, are they in sequential order, things like that. So that edge fitting is an individual property. Most of what we're going to see about glass, though, is class characteristics. So what is the composition of the glass? What chemicals are in it? All glass is not quite the same. What is the density of it, and what is the refractive index of it? Those are the three we're going to focus on. Also, if I have something hit a piece of glass and go through a projectile, like a bullet goes through a piece of glass is the typical context. If I can study the fracture pattern, if the glass is kind of intact and I can study the fracture pattern, I can tell some things about it. One, I can tell which side the projectile hit the glass from. Did it hit from, the front side of I can tell from which direction the projectile came. Also, if there's a lot of different fractures on it, so I have multiple bullet holes, for instance, I can tell the order of the bullet holes, which one was shot first and which one was shot later, and that can be helpful in detective work. So when we collect our glass evidence, we do need to be thinking about that. Remember, we're always going for individual. If there's even the remotest possibility that I can collect all the glass fragments, so I might be able to piece them together, I want to make sure I'm collecting them all. So I will try to do every effort to collect all the glass. If it's just not going to be likely, there's too much damage and crushing of glass, and I don't think I'm going to be able to fit fragments, then I want to submit the glass evidence found in possession of the suspect with a representative sample of the broken glass. So maybe I don't do all of it, but I have the glass from the car accident and the glass from the vehicle, the suspect vehicle or something like that. I would also want to have a reference sample. So if I'm taking glass from where it was broken, where it was hit by another vehicle, I would also want to take some glass sample from that same window, headlight, whatever, close to where it was impacted, but where it's not broken. And that will give me a representative idea of what was the glass in that headlight or in that window like compared to the area where it was broken. Also, if it's a car accident, we do care about whether the lights were on or not. So if the headlights are broken, it turns out that photographing the headlight, the light bulb itself, can tell us from the analysis of it, we can tell if the headlights were on at the time of impact or off. Obviously, for liability reasons, that's pretty important. So we would be photographing the headlights if the headlights are broken. Also, we don't want these glass fragments to break any further, right? Especially if we're piecing them together. So we want to protect them from further breakage by placing them in some kind of rigid container. So a variety of options, it might be in a druggist fold, in a rigid container, in a box, in a vial. So a lot of times you use some kind of vial. A plastic bag is not really going to protect it from being crushed. So something like a vial or something with a screw top lid or a hard box could also work. If we have debris from glass shards that I might be looking for on the suspect's clothes or their shoes, I want to kind of take that whole sample and send it into the lab. So I would take the shoe or the piece of clothing, wrap it in some kind of tissue or some kind of paper so that those little shards, as they fall off the piece of clothing or if they fall off the shoes, are still going to be contained and can be analyzed. So those are going to be our collection specifics that we worry about when we're talking about glass evidence. Another thing that we're going to talk about is sometimes I can get some probability. We talked about the importance of statistical probability when we have class evidence. So for instance, if I find a piece of glass and it has a specific density, if that density is a rare density compared to other glass densities, that might tell me that this piece is more likely, these class characteristics, I have a better match, better probability that these two pieces having the same density means something significant. So we will talk about probabilities, and we will practice how to measure probability from a distribution. So the idea would be you'd be given a distribution of here is many, many pieces of glass in this particular thing, its refractive index being measured, and saying, if I just take many, many samples of glass and I measure their refractive index, what typically is these ranges of refractive index? So for instance, I see this one is a pretty common refractive index. I see many of those pieces of glass have this one. This is my highest probability. And then the ones that are very small are pretty rare probabilities. And I could do this for any property. I could do this for a refractive index, for a chemical composition, for a density. So this concept of being able to use this is a pattern, a frequency distribution from taking many, many samples. This is provided. And the probability of a specific event, of a specific type of refractive index or density, is going to be the number of occurrences of that event over the total number of the occurrences. So in this particular example, so I have this area here, which is magnified, that we're going to talk about on the next page. Okay, so this specific one, if I wanted to say, so I measure a piece of glass, it's got a refractive index, my individual piece from the crime scene, of 1.5160. And I want to know, well, is that like a common, or in this case, 1.5161. And I wanted to know, like, well, how probabilistic is that? Is that like a common or not so common piece of glass? From that distribution, and this distribution, I have to kind of look at when that distribution was made, how many pieces of glass did they sample? In this case, they took 2,000 samples. So that's my total number of occurrences. And then I need to find, well, how many times did 1.5161 occur? So I'm looking at this, and I kind of have to back it up. No, this is 30, this is 40. You have to make some, in this particular case, I'd have to have some off of a graph. I have to estimate that that's 32 or 33. It's definitely less than 35, between 30 and 35, and it's kind of about a quarter of the way up, so 32, 33 would be a good guess. So my probability is then 32, the number of times I saw that one, divided by 2,000, the total number that were measured. I multiply it by 100 to get it in percent, and it turns out this is a 1.6% likelihood that any piece of glass you would find would have a refractive index of 1.5161. So I'm taking a sample of 2,000 to kind of represent all the pieces of glass in the world. So we will be able to I will give you a distribution, and you will tell me a probability of a certain specific one. Obviously, if I hadn't done 1.5161, but it was this one here, down here, this 1.5151, this would have a different probability because this one's like 9 instead of 10, so instead of 32, there's like 9 occurrences. So it's more rare. So we get the idea of how to do that. And that's going to be an important part in this class.